Hello everyone. Now I am going to discuss the topic about integral calculus and Fourier series. Integral calculus is the branch of calculus where we study integrals and their properties. Integration is an essential concept which is the inverse process of differentiation. Both the integral and the differential calculus are related to each other by the fundamental theorem of calculus. In this session, you will learn what is integral calculus, why it is used, its types, formulas, examples and applications of integral calculus in detail. Next, we have to show integration calculus. If we know the f dash of a function that is differentiable in its domain, we can then calculate f. In differential calculus, we used to call f dash the derivative of the function f. In integral calculus, we call f the antiderivative or primitive of the function f dash. And the process of finding the antiderivatives is known as anti-differentiation or integration. As the name suggests, it is the inverse of finding differentiation. Now, types of integrals. Integration can be classified into two different categories, namely definite integral and indefinite integral. Definite integral, an integral that contains the upper and the lower limits, that is start and end value, is known as definite integral. The value of x is restricted to lie on a real line, and a definite integral is also called a Riemann integral when it is bound to lie on the real line. A definite integral is represented as integral a to b f of x dx. Next one is indefinite integral. Indefinite integrals are not defined using the upper and lower limits. The indefinite integrals represents the family of the given function whose derivatives are f, and it returns the function of the independent variable. The integration of a function f of x is given by capital F of x, and it is represented by integral f of x dx equal to capital F of x plus c, where right hand side of the equation means integral of f of x with respect to x. Then f of x is called antiderivative or primitive, and f of x is called the integrand, dx is called the integrating agent, whereas c is called the constant of integration. At last, x is the variable of integration. Now we can see methods of finding integrals of functions. We have different methods to find the integral of a given function in integral calculus. The most commonly used methods of integration are integration by parts, integration using substitution. It is also possible to integrate the given function using the partial fractions technique. Now, uses of integral calculus. Integral calculus is mainly used for the following two purposes. To calculate f from f dash, if a function f is differentiable in the interval of consideration, then f dash is defined. In differential calculus, we have already seen how to calculate derivatives of a function, and we can undo that with the help of integral calculus. And another one is to calculate areas. Now, we can see applications of integral calculus. The most applications of integral calculus are as follows. Integration is applied to find the area between two curves, center of mass, kinetic energy, surface area, work, distance, velocity and acceleration, the average value of a function, at last volume. Next topic, multiple integral. First one is double integrals. Double integral is defined as the integrals of a function in two variables over region in R square. Next one is triple integral. As the name implies, triple integrals are three successive integrations used to calculate a volume or to integrate in a fourth dimension over three other independent dimensions. Next one is change of variables. In this topic, we have generalized this idea and discussed how we convert integrals in Cartesian coordinates into alternate coordinate systems. Now we will end up the session. Thank you.